Good afternoon. My name is Farhad Ameri. I am Associate Professor of Manufacturing Engineering at Texas State University. My presentation today has 3 modules. The first 2 modules are not ontological or not philosophical at all. It's more applied. And what notion of capability in manufacturing, why do we care about representing and analyzing manufacturing and capability. Part 2 is about the terminology that companies use for describing their capability, because eventually if suppliers or companies are going to use capability ontology, their notion of manufacturing capability should kind of match with whatever we encode in our ontology. So that's why it's necessary for us develop a sound understanding of what capability is from the perspective of the bearers of capability. The last part is just an overview of the CAMDIF project. It's a DMDII project which is related to capability modeling for digital factories. I'll give you just some idea about the project, and I cannot do a demo because it's on my computer, but I can show you some of the screenshots of the tool that we are developing. Okay, so first of all, really, why do we care about capability in manufacturing, and why understanding and representing it is necessary? Well, there are multiple reasons. One is building manufacturing partnerships and building supply chains. So if you want to select this partner, we need to know what are the capabilities of that partner that can be included in our supply chain or outsourcing. Does the company has the required set of capabilities for us to do the job for us? Design for manufacturing, Tom actually provided some good examples. If you are designing an artifact, you need to understand, first of all, what are the capabilities of our facility before we can actually go ahead and design it. And from a strategic planning perspectives, so the companies need to know where they should be in terms of competency and competitive advantage in order to be able to compete in the market. So these are some of the reasons that it matters for us to understand and represent capabilities. So first, in the context of business strategy, the term capability really entered the literature of manufacturing in the 60s when Skinner, who was one of the pioneers in manufacturing strategy, published this paper in Harvard Business Review, and the goal was really link capabilities to strategies. So he was kind of comparing a bottom-up approach to a top-down approach. Bottom-up approach being that most companies just collect a bunch of resources, and based on those resources, they obtain a bunch of functions and capabilities, and then some competitive priorities or capabilities or strategic capabilities may pop up as a result of having those resources. But he actually advocated for basically the top-down scenario, that companies should first understand what are their competitive priorities, and based on that, collect the capabilities and then functions and resources. At that time, in 60s and early 70s, these 4 capabilities or competencies were identified as core or key capabilities: quality, cost efficiency, dependability, and flexibility. And they remain kind of the dominant set of capabilities, and many other researchers use the same 4 concepts or basically types of capabilities, and they refer to it as generic capabilities, being again cost efficiency, quality, dependability, and flexibility. And that's how they are defined. As you can see, dependability has 2 aspects: delivery dependability and service dependability. So flexibility, ability to instigate a rapid design and rapid volume changes. And innovation was another capability that was added to the set later, maybe 80s and early 90s. So then if you want to have like a pyramid of capabilities, a set of lower level capabilities, on top of that, we have competitive priorities being those 5 things. But the question is how this evolution is happening until we get basically those top level capabilities. The other argument or issue of discussion in the research community was that well, should capabilities be obtained at the expense of the other capabilities, or basically do we build capabilities upon each other? So that's why they were calling trade-off model versus cumulative model. That's an example of a cumulative model or SandCon model developed by Hayes and Wheelwright, again, in 80s. So, and from their perspective, so it was a progression, and companies should start with quality, and based on that, go to dependability. And if they have these two capabilities, then they can move up to speed of reaction, and eventually they obtain cost efficiency. So that progression should be followed based on their perspective. And there were a lot of surveys on those 4 or 5 capabilities to understand which companies have what type of capabilities. Does that progression that what is stated here, is it actually meaningful? Are there use cases or actual data to support that progression or not? So that was an interesting study that was done in 2002. They studied 371 companies over 11 industries. And for example, this figure shows that the companies with 2 capabilities, like quality and delivery, 24 companies had these 2 capabilities coming together. Apparently, they are a good match. But maybe there aren't many. Flexibility and delivery, not that many. So it's interesting that flexibility and innovation, there were 20 companies that have those 2 capabilities. So there's a natural matching between capabilities depending on the culture of that organization. And here we can see companies with 0 capabilities. Obviously, there is no company with 0 capability. You cannot compete. So you should do something good. But there are some companies with at least 1 capability, and 2 and 3, and well, there were, out of that 371 companies, there were only just few companies that had basically 5 capabilities. So that's the other thing. So how many capabilities should companies aim for? And is it humanly possible even to get more than 5 or 6 capabilities in terms of strategic capabilities? I'm not talking about low-level operational capabilities. It's more on high-level strategic capabilities. So that was very interesting. And the other, actually, in the same experiment, the metrics they use, these are the metrics they use. So again, the notion of measuring capability is there, and people can connect with the idea of capability being measured along a scale. For example, in terms of quality, so first pass yield, that was the metric they used, or percentage of on-time delivery for delivery capability, manufacturing cost as percentage of sales for cost capability, average total lead time for flexibility, and percentage of sale from new product for innovation capability. So these were the metrics that were used in that research. And again, the question is supporting and nurturing many more than 4 core competencies may prevent a firm from developing the focus needed to fully exploit its competencies in the marketplace. So that was the result of the study. So capabilities were studied in conjunction with the resources when the idea of resource-based view of the firm was introduced. So a resource-based view of a firm views a company as a bundle of resources, capabilities, and competencies, and competencies being strategic capabilities, right? That can be used to create a unique market position. That's the resource-based view of the firm that in manufacturing strategy studies, they are using that view a lot. So, and here the definition, again, resources are assets, tangible or intangible. Knowledge is a resource, machine is a resource, human. These are all considered to be resources. Capability, and that's when Barry were mentioning to circular definitions, that's an example of circular definition. So capability is a firm capacity. So again, the question is, what is the capacity? That was kind of a predominant definition of capability that many authors kind of use the same definition. The firm's capacity to deploy resources that have been purposefully integrated to achieve a desired end state. So what's desired end state? And, we are not going there, but you can see the resources appear here. So capability arises from resources, and competency are distinctive capabilities that basically allow a company to stand out. So resources are sources of firm capability. Capabilities in turn are the source of firm competitive core competencies, and a firm core competencies are basis for competitive advantage. So resource enable capability become a core competency, and core competency drive the strategic competitiveness of the company. So that was the resource-based view of the firm. And for a capability to be considered a competency, they are identified 4 qualities: valuable, rare, costly to imitate, and non-substitutable. So if a capability is easily imitatable, then that's not a really good competency for the company. Or it's not rare, then that's not a good capability to invest on that. So they are required for sustainable competitive advantage. Well, these are some examples of capabilities for different companies in different functional areas. Like in distribution, Walmart is well known for its capability in logistics. So an ability to use logistic management techniques, that's Walmart's competitive advantage. Or for Starbucks, ability to motivate employees. Because the topic of the presentation is more on manufacturing, so these are the highlighted capabilities in terms of manufacturing. So like, for example, Toyota, the ability to design and manufacture high quality products. That was their source of competitive advantage. Well, some observations based on the resource-based view of the firm. So capabilities are often treated as abstract entities whose specific meaning always depend on the context. So really, there is no global definition of capability in literature of manufacturing strategy. Competency is used synonymously with capability, which makes sense because competency is one type of capability, which is more a strategic type of capability. The distinction between capabilities and the resources is not definite. So having a machine by itself is considered a capability, but the machine is an enabler. So that's kind of a confusing part of this definition. There is no clear distinction between knowledge and capability. So just having knowledge by itself is not capability. Knowledge should be treated as a resource. And again, there are lots of vague definitions of capability. I selected some definitions, but you can see like the ability of an organization to perform a coordinated set of tasks. So again, you really don't get a real understanding of what does that mean. Or intermediate transformability between resources and objectives. Maybe they're referring to that from resource to capabilities, but again, transformability again doesn't tell us much. So confusion is there, vague definitions are there. But on the positive side, many of the attributes of capability as defined in the literature match with defining capability as a disposition. Capabilities are treated as potentials or capacities. Question?
Could you go back to the previous slide? So the dates that you're presenting now, 2003, is that because there are no better, more recent attempts to solve these problems, or because it was fashionable then?
Well, some of them were the author, the definition by the author. So really, there was not overall accepted definition for capability in literature, except for the definition provided by NANCA. So these are maybe as many of these definitions are provided by the authors because there is no definition. There is no good definition that people can read.
And still today, no?
Yeah, exactly. So capabilities can be measured. They are linked to resources, and they endure in time and evolve over time. So they comply well with our notion of capability as a disposition. In terms of types of capability, going back to that pyramid. So again, that comes from the literature. There are two main categories of capability: second-order capability and first-order. So second-order capabilities are dynamic capabilities, the ability to obtain capability, or the ability to mix and merge capabilities. Those type of capabilities are considered second-order capability. But down this pyramid, at the lower level, we have first-order capabilities, which are more operational capabilities. Like market capabilities or technology capabilities or any other capability that is related to day-to-day business of the company. So there is really not well-defined subcategories for technology capabilities, but these are some that I think which people truly believe that they matter and they should develop those type of capabilities, like design capability, production, and fabrication capability. So Tom provided some examples for machine capabilities. So but machining capability can be applied to a machine tool, can be applied to a machine cell, or can be applied to a factory. So it has an object aggregate, collection of different objects. And what are different aspects of machining capability? So the level of complexity capability, or precision capability, how precise we can machine the components, or what's the best surface finish that can be generated through machining, that surface finish capability, or what's the length on the biggest part that can be machined. So there are different aspects of capability for each process, like material capability, feature size capability, speed capability that can be applied either to a machine tool or a machine cell or to a factory. And we have this notion of vertical dependency. The precision of a machine depends on the device, like the axis, the feed axis of the machine, X, Y, Z, obviously. And then the precision of machine cell as a whole depends on the precision of its least precise machine in the cell, and so forth. So there is this vertical dependency that appears a lot in a factory. So that was end of part one. So part two is more on the terminology. So the research question was how contract manufacturers advertise their capabilities. And what type of capabilities are emphasized more than others, what terms and phrases they use, and are there any jargons that they use when they define their capabilities. So if you go to a website of any contract manufacturer, most probably there you should be able to find a link for capability on the main menu. And when you go in the link, there are pages of related to capability that describe machines, describe resources and materials and so forth. So our question was, okay, let's analyze those pages and see how they are using their capabilities and how they advertise their capabilities. So if you go to a typical website of a manufacturing company, you see some terms like heavy parts, precision machining. Some of them point to type of parts that are being produced by the company in the past. Some refer to what type of processes they provide. Some talk about the industries or customers they serve. So they're kind of trying to indirectly tell us what they do. Maybe it's not a direct way of their capability presentation, but these are key terms and entities and notions that we need to learn and categorize. So in the research, we really focus on 500 companies in precision manufacturing, and they were all small and medium-sized companies. And we kind of browsed and parsed their websites and try to capture all the key terms or key phrases that somewhat point to an aspect of manufacturing capability. So we collected about 1,000 terms and phrases and put them in a scarce thesaurus. So thesaurus doesn't have the complexities of an ontology, so it's easier way for collecting terminology. And so some of them are preferred labels, some of them are alternative labels, and we managed to categorize them under engineering capability, general capability, industry, manufacturing, organizational, and quality capability. So these are the main categories of capability that companies care about. And that's an example of production capacity that goes under manufacturing capability. As you can see, they use the terms like heavy production volume, high mix of low volume, small prototype batch, long run production. So these are the terms and phrases they use for describing their capabilities, and many of them refer to the same thing. So in this course, we managed to link them through alternative label. So if this high production volume is a preferred label, then high volume production runs becomes the alternative label. So here are part type. Companies would love to use past cases of production and to tell us about what they have done. So they say, when you say the term long part, it really means the ability to produce long part, or the ability to manufacture precision machine parts, or the ability to machine aluminum parts. So that's one very good way for us to learn about what the companies can do. And some of them are related, like precision machining parts are related to complex precision parts because the precision is implied in all of them. So, and that's the terms companies use for geometry complexity. For example, intricate contours or delicate cavities or unusual shape. So they say, okay, we machine unusual shapes. So there's something that you can learn from that the fact that the company can machine unusual shape, it means that they have enough machining knowledge and resources. And then we did some basic frequency study. Well, out of those 6 categories of capability, manufacturing capability had the highest frequency in terms of number of terms and concepts. And if we just go into that first column under manufacturing, companies usually use processes. That's why what they really emphasize more than anything else about their capabilities. And then after that, we have parts, equipment, what type of machines they have. They really want to advertise type of machines they have, the materials they can machine, and so forth. And then later on, we created a tool to basically parse different websites and see how many of the terms are appearing in the websites of different companies and kind of get a feeling of what the company do. So in that way, we can, for example, do classification of companies based on their capabilities. So instead of dealing with free text, we are dealing with a vector. It's more computable. So to analyze capabilities, if you have a vector of terms that we are dealing with. So lessons learned from this part of the research: technology capabilities are highlighted more than other types of capabilities, more than market capability, more than organizational capability. Organizational capabilities are really emphasized in larger companies, and use of industry jargons is quite common. So like many terms like turnkey in manufacturing, for example, that's not an official word, but many companies use that turnkey service or turnkey manufacturing. And there are lots of unofficial jargons or trade words and phrases that companies were using. Okay. And part 3 is about the DMDII project, CAMDIF. In this project, the objective is basically to develop a method for understanding capabilities of companies in the context of supply chain formation. Because right now, supply chain formation is a manual process. There isn't much intelligence involved in many supply chains development solutions. So the goal was to increase the intelligence and automation of sourcing platforms and solutions through using information and communication technology. And obviously, using an ontology was a good way for enhancing the intelligence of the solution. So in that, we created digital factories, and digital factories are actually ontological representation of real factories. And the tool was geared to our enabling automated inference and reasoning about capabilities of companies. And also we need to measure. So we need to define capabilities and find measures for quantifying capabilities of companies. And well, the fact is that if we can use ontology for describing capabilities in a standard way, and if we can share that ontological representation of a factory, then it's really easy to browse and search companies based on capabilities as opposed to just doing Google search based on key terms. So the tool that we developed, it had 3 functions, build, match, and analyze. And you can see some idea of the system architecture. So the ontology we used was MSDL, Manufacturing Service Description Language. So it was developed as part of my PhD in like 2006 in Michigan. But through this project, we try to align the ontology with BFO. So we use BFO as well in the first layer. So we use Jena for semantic, basically, layer, and then these are the functions. But digitizing the factory is where we build the factory, and then we have capability inference module, capability visualization module, and supply chain creation. So these are some of the classes of the ontology. As you can see, manufacturing company, which is an organization, has parts such as human, factory, method, production, software, raw material, and they can play a role of customer or supplier. And then again, the factory, which is an object aggregate, is composed of factory equipment. So in the ontology, we had to describe the equipment of the factory very clearly because they are enablers of capabilities. So here is one way to quantify the capability related to surface roughness. So it is a capability. Well, maybe it's not part of BFO yet, so I shouldn't use that. But as a capability, which is measured as a length measurement datum, because surface roughness is actually the average depth or height of this roughness on the surface. It can be measured as a length measurement datum, which has a value and has a unit. So for whatever we are measuring, we have this kind of concept model. And that, yeah, of course.
I can wait.
No,
can you go back to that slide? So when I see surface roughness, is the capability that you can measure it or that you can control the surface roughness? It seems like surface roughness is a property of some surface,
yes.
Something. So the capability would be in controlling that roughness or in measuring that roughness?
It would be producing that roughness.
Producing.
So the machine, that machine is a surface like a milling machine. So some machines produce very smooth surfaces, some machines produce like coarse surfaces. But that's a surface producing capability.
So could we call that surface roughness production capability?
That's a good way to describe it, yes.
Okay. And is it a measure of goodness or badness?
Well, I mean, it is goodness, obviously, because we want, well, it's a measure of conformity. We have a requirement, and we would like to conform with that requirement. So as long as we are within that range, so...
Okay, so the smoother, the better.
The smooth, not always.
Okay, that's the question.
Yes, sometimes if you are going very smooth, then the cost of manufacturing goes up. So...
Okay, but there are surely cases where people want to build rough surface objects.
Yes, that's right. So it might be vice versa. I mean,
yeah.
it's not either direction.
Yeah.
So I'm just trying to understand this a little bit. This is a digital model of a factory. Did you actually build this? And is this tied directly to this factory? Are these inputs being fed through the machinery into a database that models this?
The data comes from the catalog or the machine specifications that come from the vendor of the machine. So the way we build the factory, we have a library of machines, like CNC machines or 3D printers. We add those machines to the factory. And then the properties or the capabilities of the machines come from the catalog. So it's not through collecting data, actual data from the shop floor. It is based on the canonical definition of the machine and whatever the the OEM is actually claiming about what type of surface roughnesses I can produce, what type of precisions can be produced. So it is based on what the vendor claims, and we assume that the claim is a valid claim correctly.
So is it static then? It's static then?
Yes, so this part is static. So suppose we add IoT and sensor data, then it becomes dynamic. So this project was more on the static side of it, not on dynamics.
So for non-engineers, what would be an example of a surface that someone would want to be rough versus not so rough, smooth?
So you're asking why we want the surface which is smooth. Like for your MacBook computer, right?
Sure.
So that's aluminum. You want to really as smooth as possible. But sometimes you need some grip. You don't want to have a slippery surface. You are designing a tool, and the handle of that needs to have some grip, some roughness. So that's why in the second situation we need higher roughness. In the first situation we need lower roughness. So it depends on the context. So I don't want to go into a lot of details, but as you can see on manufacturing capability, we have a subclass called part quality capability. So these are all the qualities that are generated on the part quality. So how we evaluate those qualities, like complexity, material, minimum feature, precision, size, surface finish, wall thickness, and obviously there are more, but within the scope of the project, we focus on all these basically measures. So these are some measures of manufacturing capability or technology capability of the company enabled by the resources or machines owned by the company. Yeah, as you can see, these are capabilities. And so we have also material capabilities. What materials can be processed? We have manufacturing processes capability. What processes can be offered? And so forth. So in that way, when we have a factory, really we can have a more formal capability model of that factory. That model can be understood by machine agents. So they are machine understandable, and because they are a standard, they can be shared and basically browsed and used on supply chain solutions or platforms that use. Of course.
Yeah, you mentioned the MSDL.
Okay.
And this is part of the MSDL.
Yes.
Could you take this model and apply this to another factory? Like if we had a factory, could you use this model? And how flexible is it?
But yeah. So
does this work for a baby formula factory as well as a hammer factory?
The scope of the project was medium and small size companies. So we didn't apply to Ford or GM or those bigger companies, like companies with like 10 machines and a few workers. So basically, and in the experimentation phase, we asked 20 companies to use the tool and kind of build their model, the model of their factories. So, and in that process, we had to add more resources because in the library, we didn't have all the machines that they were needing. So we managed to add and extend the library. And the goal was to make it very user-friendly. So we try to hide all the ontological complexities, and the users, they don't see the ontology. They just see the user interface. It's a bunch of drop-down menus, and they can select from. But yes, we focus on the small and medium-sized companies for this project. Yeah, so machine agent can understand what the company can do. So that was the ultimate goal. Well, I wanted to do a demo, show a demo, but because I'm not connected, I'm just going to show you some of the screenshots.
So Anthony has a quick question. It is part minimum feature size capability sounds like a defined class that may not have ontological relevance. That is there a universal part minimum feature size capability, or is this purely a logical construct?
For sure, it's a defined class. Yes.
He said, for example, there's no such thing as people who walk their dogs on Tuesdays. Instead, this is a logical construct that relates several universals.
Yes, that's right. I mean, it's not a universal class, so we have just defined it for the purpose of quantifying the smallest feature size that can be manufactured. And it is useful in the context of manufacturability analysis. Maybe in other contexts it doesn't make sense. It's a defined class and it's a logical construct. It's not a universal class for sure.
I'm curious about capabilities that are sort of bridging the user and the machine or the user and the factory. Like you brought up usability or being user-friendly.
Mm-hmm.
Are those considered capabilities in this sort of thing?
Well, that is maybe the feature, the capability of the application. So we wanted to make it user-friendly such that like regular people that have no idea about ontology can use the tool and represent their capabilities. So that is not a capability which is within the ontology, but it is the capability of the application. Yeah. Did I answer your question?
Yeah. It just seemed like a kind of funny area between, you know, the human beings involved in the machine.
That's right.
Yeah.
Exactly.
At the beginning, you had, I think, 4 or 5 maybe things that you were calling capabilities. What were those again?
Well, cost, quality, dependability, and flexibility. They were defined as strategic capabilities. So at the top level, a company becomes competitive through those high-level strategic capabilities. But they are enabled by lower level capabilities.
It just seems like a peculiar way to say that cost is a capability or quality is a capability. It's more like, like something you want to say about if we have a machine capability, we can say that it's cost effective, we can say that it's high quality, etc. So those don't seem like capabilities, they seem like things we want to say about capabilities.
Exactly. That's a label that they use for describing capability. If I want to use a better label, it's the ability to produce low-cost products. That would be a better label, just than cost only by itself. But well, in 60s and 70s, when they were talking about manufacturing strategy, so cost and quality were key terms that people were referring to. But so yeah, it is not the best label for a capability.
So, sorry, following along with the question about the interaction between humans and the machines. So if I understood correctly, you're modeling these facilities by saying they tell us they have these machines, and then we look up the information for those machines, and now we know what their capabilities are for that company. But then, so on this model, then 2 companies that have the exact same machines would have the exact same capabilities. Is that right?
Well,
so
no,
even if like one has expert machinists, another one has novice ones.
Exactly. So skill is another aspect of the capability that needs to be added to the set. Just having a set of machines doesn't mean that you have more capability.
Right.
So yeah, we did not include skill in the software, but well, it is included in the software. It's not included in the capability analysis. But in reality, yes, that really matters. Who is using that machine?
Okay.
Well, just quickly, I can give you an idea of what is this software about. So there are 3 functions: build, analyze, and match. So you define the company, what's the company, and what's the size, like what type of company it is. And then over here, you can basically add equipment. So these are the resources. You say, okay, I mean, and this structure is directly coming from the ontology. So different types of machine tools. Suppose we want to add a vertical milling machine, and these are all instances of vertical milling machine. And as we test this tool more, we are adding more instances of machines. And then, well, these are some of the properties that we looked up from the vendor's website. And well, in this way, more machines and 3D printers are added to the factory, and then basically once you have that, you can add material capabilities, what type of materials can be machined, and you can add software, what type of software applications are available. So in that way, you are kind of evolving and extending the capability model. But whatever you have here, these are basically resources or artifacts that kind of enable capabilities. They are not capabilities themselves. So and then you can generate the RDF XML model of the factory, and then that's what you can share, and you can analyze more. The analyze function really goes on each factory and analyzes the precision capability, part length capability, diameter, and so forth. And there's a notion of inferred and explicit. So there is some explicit capabilities that come from the catalogs of the vendors, but we go over class-subclass relationship to figure out maybe they are more capable than what they are claimed, or maybe they are less capable than what they are claimed based on what other types of subclass relationship exists between these machines and all these resources. And well, you can always export the model, and this whole idea of using ontology for sharing capabilities is very valuable. We are using standard terminology, standard syntax and semantics that makes life easier for users of the system. Yeah, so I guess that was the last slide. So on other issues, maybe, yeah, not sure.
Did the companies that participated in this, did they get any insights that they gained from the analysis? Did they change their capabilities? Did they?
Well, obviously, the input that we received was more about, well, we have a lot of resources and machines that are not in the library, and so that was input for us. In terms of any insight they have gained, well, the fact that they need to use a standard way for describing their capability, that was something that never occurred to them. And in a few conversations we had with some of them, they said, oh, wow, we didn't know that we should really be very specific about what we can do. So some of them decided to go on their website and just revise their website and just have a better advertisement of what they can do. So, but bringing capability to the surface and just making the case that it matters that you define what you can do in a more structured way, it is critical. It pays off at some point. So that was the feedback I received on a few of them.
But they weren't able to, they didn't add value to their customers and the product.
Well, we didn't go that far because the life of the project was kind of too short. So maybe if we do follow-up, we'll see what they have gained and what they have learned from this project. But at this stage, just the fact that capability matters and they should be more explicit about it, that was an interesting observation for us.
This seems like it might apply to adjacent knowledge. So, for example, you have a capability, and the customer has a need, and it's not quite a perfect match for the capability, but no one else is any closer. So you have some adjacent knowledge, some adjacent capability that's close enough, and you can modify it to then make it match.
Exactly. That's one of the power of using ontology, because partial match is still a match, kind of. So yeah, and one of the extension of this work is kind of to rank suppliers based on their level of capability in terms of meeting the needs of a given work, basically work order. Yeah. So that, of course, that's a very useful feature of using ontology.
How important is, so when you identify a capability that a machine can do, for example, how important is it to identify the other capabilities that are bundled together for that making? Because, and does the ontology, would a good ontology, you think, be able to identify those things? Because then when you get overlap, you can figure out which elements of the bundle are overlapping.
Yeah.
So I'm not sure if I made my question clear, but it seems
No,
like
but
this is
exactly. I mean,
important.
the question of skill and machine. I mean, that's a bundle. So if I have a 3D printer, I don't have the knowledge of using 3D printer, then it doesn't make sense. So that human skill is an element of capability that I need to have. I need to have the machine. Maybe I need to have software or other resources. So yes, bundled on capabilities is exactly. I mean, most of manufacturing capabilities are bundled capabilities, I would say. But if they start from very elemental, basic capabilities, like precision. Right? But then if you want to machine larger part, then your transportation capability becomes a factor. Do you have that or not? Just having a huge turning machine doesn't mean that you can machine big pipes. You need to have the right lift trucks and right equipment. Yeah, so in fact, it makes perfect sense, and most manufacturing capabilities are bundled from my perspective.
So I'm assuming that you are Mr. Capability when it comes to the manufacturing world, so that there is no one who knows all the things that you know about manufacturing capabilities and work on manufacturing capabilities.
You mean in academia?
Yeah.
Well, people are working on capabilities, but not from the perspective of ontology. So people are trying to quantify capabilities.
Yes.
But defining capability, coming up with a universal definition, it was not a concern for many researchers.
Yeah.
That's why I've not been able to find those definitions, but people are working on capabilities, but from different angles.
Yeah.
Yeah, so for quantification or using machine learning to classify companies based on their capability data. So it's kind of more specialized applications of capability.
Okay, and what about capabilities involved in maintenance? Is there literature on that?
I mean, there is a huge literature on maintenance. In fact, there are lots of maintenance ontologies, and obviously none of them work with each other, so they are isolated ontology. But capability of maintenance, not that I know of.
Okay, so I'm interested in capability of maintenance in part because healthcare is a maintenance industry.
Oh, okay, yeah.
So, but there the products are human beings who go through supply chain from one hospital to another.
Yeah, that's interesting.
And the Air Force has a whole set of organizations which are interested in aircraft health.
Okay.
And they do aircraft maintenance, aircraft health diagnosis. So there are a number of parallels between the healthcare industry and the manufacturing industry, primarily in the connection with maintenance.